Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 20 in our incredible new tutorial series where you're going to unleash the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, my life and your life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to make temperature and humidity measurements using the DHT11 sensor in your Kepler kit. Okay, now up until this point in the lessons, in the first 19 lessons of this class, we've really laid a solid foundation for you to be successful moving forward. So to kind of recap what we've learned how to do digital writes. We've learned how to do analog writes using PWM. We've learned how to do digital reads, and we've learned how to do analog reads. And so with those four building blocks, we're now ready to dig into our kit a little bit deeper and to start using some of the more interesting components. Now, up until this point, we've done a lot with push buttons, with the potentiometer, and with LEDs. So we've kind of used these simple components. And the reason is that they're very low cost components. So as you're learning, if you make a mistake and hook something up wrong, you burn out something that's a very inexpensive and easy to replace component. But now we've gotten some experience in building our circuits and doing our coding correctly, so we're ready to move on to a more advanced component. And so, as I said, we will be moving on to the DHT11 sensor. And where it is in your kit, I will show you up on the top level of your kit, there is this little bag of electronic goodness with all of these different things in it. What you'll want to do is you'll just kind of want to dig through that little bag, and you'll want to find this little, I got a bug on my board. Do you see that? Okay. I'm easily distracted. I'm sorry. You've got this little square blue sensor that has 4 leads coming out. Okay, let's look at how we hook this up. There are 4 leads. We will only use 3. The first thing we are going to do is come over here to pin 3, the third pin over here on the Raspberry Pi Pico W. When you are in this configuration and you come over 1, 2, 3 to the third pin, you have a ground, and we're going to bring that down and establish the ground rail. Also, you guys always have this little card from the kit handy because it really makes it easier to hook these things up, and you can follow along with me, but have your little pin out card from your kit out so you can kind of see what I'm talking about. Okay, we skipped the 4th pin, and then the 5th pin is 3.3 volts out, and so we use that 5th pin to come down and establish our power rail. So we've got a ground rail, we've got a power rail. Then we come over to our DHT11 sensor. The leftmost pin, pin 1, the leftmost pin, comes down and goes to the 3.3 volts. Then the second pin I'm bringing over to this corner GPIO pin, which is physical pin 21, but it is GPIO pin 16. So make note, GPIO pin 16. And then the next pin, the third connection, on the third leg of the DHT11, we skip, we don't use that. And then the fourth leg, or the rightmost pin, we come down and ground. And so with this, this should all be hooked up correctly. And then if you'd rather look at the schematic, maybe it is a little clearer to see up there. I've got that for you too as well. Okay, so go ahead, take a second and get your sensor out and get it hooked up, and then we'll be ready to code, okay? So let me come over here to our code view. Okay, I believe that is a nice looking code view. And let me get my keyboard arranged here a little better. This is actually a pretty easy sensor to use. And the good news is the library, the MicroPython, the library to work with the DHT11 comes with MicroPython already. So when we installed MicroPython, we should have this library. We shouldn't have to install anything, if that makes sense. So let's come in and let's say from machine, we're going to import pin, and you guys should be familiar with that. You got to import pin if you're going to be working with your GPIO pins. Now also we're going to want to put a delay in there, so I like to import U time, and I think the U is the kind of Greek symbol for micro. And so when I think it's saying import micro time, I think it's like the MicroPython implementation of the time function, but I'm going to import it as time. So now I can just refer to it as time. Okay, now from DHT, I'm going to import the method DHT11 like that. Okay, so now I should have the library that I need in order to interact with my sensor. So this is going quite easily so far, I must say. All right, now what pin am I connected to? Well, my data pin is equal to pin 16, right? GPIO pin 16. Now, what I'm going to do is I need to set that pin up as an output. So I'm just going to call it my pin, and I need to set it as an output, and I'll explain why in a minute. Well, I guess I should explain why now, because we're going to be reading from that data pin. So intuition would tell you that it needs to be an input, okay? But this is the thing. We need that pin to have a pull-up resistor. We need that pin to have a pull-down resistor to ground, and so we've got to set it as an output and then activate the pull-down resistor, and then we just pass that pin to the DHT library and it sorts it all out. But it needs a resistor in there, so that's what we're going to do here. I'm going to say my pin is equal to the method pin, and which pin am I working on? The data pin, which is pin 16. Okay, and then I need to set it as an out, even though that is not intuitive. But then here is where the action happens. I'm going to say pull down. So I'm going to turn on that pull down resistor like that. Okay, so that should get it in there, I do believe. And then I am going to say sensor is equal to DHT11. So now I'm creating my sensor object DHT11, and then which pin? Well, it is going to be my pin. So we're passing it that pin that we've already set up, and already set up the pull down resistor on there. Okay, I hope that makes sense. Now we're going to come in, and this is going to be pretty easy. While true, when is true, true, true is always true. We are creating an infinite loop. And now what we got to do is we've got to tell the sensor to make a measurement, and that is sensor.measure. Okay, and that is, yeah, I called it sensor, so sensor.measure. Now this doesn't return anything. This is just calling the object sensor and the method measure, and it's telling the sensor to make a measurement. It's not returning anything to us. It is just off there in the library, and with the sensor it's making the measurement, okay, but it doesn't return anything. To get a return, what I'm going to just say is it returns temp C, temperature C, and we get that by saying sensor, the object dot temperature, the method, and then that will return to us the temperature in degrees C. Okay, and then also I'll just say hum for humidity is equal to sensor dot humidity, and be sure to put those open and close parentheses on there. I believe that I should have the temperature and humidity at this point. So let's just do a simple print and let's just see if it's there. So I'm just going to print temp C, comma, humidity like that. And then very important, you want to put a time.sleep of about a second. If you pound this sensor too hard, if you're making measurements too quickly, I found that it doesn't work very well and you can actually get a bad read or you can get unusual data. And so I think putting a second between measurements is a good thing to do. And also really on something like temperature and humidity, those are slowly varying signals. So it's not something that you would need to be making 100 measurements a second or something like that. Could it really be this easy? I ask you, could it really be this easy? We will see. So I'm just going to look, sometimes a lot of times when I put pin and the P is uppercase, kind of like I don't get my finger off the shift quick enough, and sometimes the I comes out uppercase as well. So I'm going to look at this because I really want this to run the first time. It means a lot to me. So I will need you all to hold your breath, okay? Boom! Look at that. 26 degrees, which is right for where I am. It's a mildly warm day. That's about 77, 78 degrees. And then we are sitting here at a humidity of about 60%. And so I live in the tropics, so humidity of about 60%. That sounds about right. And the temperature is 26. And so that is really neat. We are getting our measurements. Now, you might be tempted to want to try and see what would happen to heat this up a little bit. So you might think about breathing on it with your warm breath to try to bring the temperature up. But the problem if you do that is your breath has a lot of humidity in it. It's got a lot of moisture in it. And when you breathe on that sensor, that moisture is going to condense on the sensor and it's going to turn into water droplets. And then you're going to get crazy readings, and you're going to get crazy readings for like 30 minutes or an hour until that water droplet evaporates. And you might actually, by introducing water droplets, you might actually cause some sort of problem with your sensor. And so I know in the real world, you're going to have high and low humidity, but just don't try to just blast it with a blast of humid breath, okay? Because I have actually caused problems doing that before. Also, you can imagine, don't come in and put a match on here to try to heat it up. What you can do is you can maybe put your fingers on it and your fingers are warm and try to heat it up that way. But just as I've been watching it, I know the sensor is working, and these things do indeed vary with time if we just let it run. Okay, that is a little bit boring. Let me show you one of the things that I learned from one of you guys on your homework assignments. What I like to do is I like to show you new techniques and new tips and new tools as we go through these lessons. And so this is something really cool I saw one of you guys do, and I'm not sure who it was, but if you're the one that showed me this, be sure to leave a comment down below that you were the one that was doing this in your homework. So let's stop this. And what I'm going to do is I'm going to come up here, and above the while loop, I'm just going to say print with a lowercase p, print. And then what I'm going to print is my sensor data. Okay, like that. And then that's good. And then when I come down here to print this, what I'm going to do is I'm going to put this strange character, a quote, and then it is the \R, and then in the quote, and then a comma. And what that character is doing, it's telling Python to overwrite the present line, not to go to the next line. And then you've got to tell it, well, for how long do you want to do that? So you got to come out here, and then you've got to tell it to end. So end is equal to like that. Just open and close single quote. Okay. Now when we do this, if I've done this right, what this should do is instead of scrolling, it should just stay in place and then just rewrite the data. So let's take a look at that and see if it works. Giddy up, look at that. So you see I've got the my sensor data that I printed one time before the loop, and then I am printing the temperature and I am printing the humidity. And so that is just pretty cool. And let's see, I really would like to make that change for you, but it looks like that it's not going to change here, but that's okay. Maybe as we're going through here, it will change by a degree, and here it's, boom, look at that, 27. So you see, when I put my fingers on it, it warmed it up just a little bit, like a degree. And then if we look here in a second, also it went to 61% on the humidity. So it could be that my finger had a little moisture on it as well. And then we ought to see it go back down to 26 here in a minute or two. Okay, but now this is not very cleanly formatted. It would be nice to have a little bit more information here. And so I think what I will do is I will come in and just say temp is equal to, and then a space, and then close that, and then a comma to print the variable. All right, and then what I want to do after that is I want to print degrees C. Now, how do you print the little degree thing? Well, there's not a degree symbol on your keyboard, so you have to print it as an ASCII character. And the way that I do that is I just say the char, C-H-R, and I happen to know, because I've done this before, is that character 176 is the degree, and then I'm just going to concatenate that with the uppercase C. Okay, and I think that should look pretty good. Now I want to put in the string humidity equal space close, and then I'll get the humidity. And then again, after the humidity, now I want to put in the percent sign. And so I'm then going to just put in the character, the percent sign, not the 5, the percent. Like that, okay? Does that look good? I think that should look a whole lot better if we do that. But let's go ahead and let's stop this. Let's hold our breath and denied line 14. What did I do in line 14? Okay, that is that crazy thing. So what I did was, that is good, and I have a comma. Temp C is good, and then I've got the char 176 plus C. Okay, then I've got the comma humidity, and then I've got the humidity, and then I got a comma, and then I forgot that trailing comma right there. Hopefully you guys saw that. The real issue is one of you didn't hold your breath. So I will need, whoever you were, I will need you to hold your breath this time. Boom, look at that. Is that not beautifully formatted? Do you see how it's not just scrolling by? We've got my sensor data, and it's kind of between 26 degrees C and 27 degrees C, and now we are up to a relative humidity of about 66%. And so I think that is just pretty darn cool. I think this has been a quick lesson, but you've learned how to use a new component. You have a new skill now. You have a new skill now. You can measure temperature, you can measure humidity, and you've got a better way to print those things out. And so I think that is pretty darn good. But now it is time for the homework. Okay, it is time for the homework. What I want you to do for the homework is I want you to get out one of these really cool buttons. Let's see. Where are the cool buttons? Where are my cool buttons? I don't see them, but you know, the buttons that have the little colored buttons. And what I want you to do is I want you to come in and add a push button to your circuit. And then what I want is, as you are operating this thing, when you press the push button, I want you to toggle between reporting temperature C and temperature F. And so you toggle, not hold down and it's F and let up and it's C. It's just when you press and release, it goes from centigrade to Fahrenheit, and then when you press and release, it goes from Fahrenheit to centigrade. Okay, does that make sense? And so you're adding a push button to this project. Let me also say, as we're moving forward, guys, don't take your circuit apart, because we're going to be adding, as we're learning, we're going to be adding to this circuit, and so your life will be a whole lot easier if you don't go in and turn, take your circuit apart, because we're going to be using this to build and learn new skills. And I hope that makes sense for you guys. I hope you're having as much fun taking this class as I am making it. I am really excited to get in and get into these more advanced components. If you like this, be sure to give us a thumbs up. Also, really helps us with the old YouTube juice if you'll leave a comment down below. If you haven't already, subscribe to the channel, and then when you subscribe, make sure you ring that bell so you'll get notifications of future lessons. And as always, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.